establishing a neighbor is conditional. There are 3 conditions. The first one is that the AS number must be consistent. Because now we use EIGRP as an IGP protocol. So it does not involve the establishment of relationships between AS. So now the AS number must be the same. Secondly, 5K must be consistent. It doesn't mean the bandwidth and latency of the 2 interfaces must be the same. That's not what it means. Not the specific value inside. But 5K, this 10100 must be consistent. 2 devices establish a neighbor. The parameters they refer to must be consistent. One of the device reference bandwidth and latency. The other can only refer to bandwidth and delay. Finally, the authentication must be consistent. Certification means the messages exchanged in the device provide authentication. It is equivalent to choosing an authentication method now. It is a means of encryption. The devices at both ends are up with the same authentication method. And both parties have a password. When exchanging messages between them, it can carry the authentication method and password for transmission. The authentication parameters in both of them must be the same to build a relationship. So why do it? For example, I have a hack. I can simulate a hello message. Then I sent you a message. I can pretend to build a neighborhood with you. You can tell me your information. Then I can know the overall information of your network now. At least it is possible to calculate the network topology. There is no problem. Now I will establish a neighbor relationship with you. We start to calculate. Because in the future we learn the overall network topology. We are going to calculate the root ourselves. Then the overall topology. I can learn. So you will find. I can break into you. This is very common. But if you want to build a neighborhood with me now, then in the message you sent, must be consistent with my authentication. I use some kind of encryption algorithm. Verification method. You must also use this method. And with the same password. Otherwise, our relationship cannot be established. It will cause the 2 of us to be unable to send messages. But by default, we do not certify. Okay. Then we're done with the theory part. We're starting to get into the experimental part. Let's take a look at the overall configuration. We have joined 2 serial lines here. Everyone can see. Below is the serial port. First of all, for R1. We first need to give the device a name. R1. After naming, we're going to start with the configuration part of the IP address. Let's do a configuration now. 12.1.1.1. Then enter the S10 interface. Enter the interface. We also go to address configuration. 13.1.1.1. Let's configure it. This is our 2.0.0 interface. Now you should have no problem with address configuration. This address is 24.1.1.2. I now ask you a question. Think about it. Above this is an Ethernet link. Because we are using the Ethernet port, the serial port is used below. Then I ask you a question now. For example, after a while, all the addresses are configured. I ping R1 and R4 respectively from R2. I also ping R1 and R4 here in R3. May I ask when R2 and R3 ping the 2 devices for the first time? Will packets be dropped? If you have an answer, you can write it on the barrage. During my configuration, you can think about this simple question. S10. The address is 13.1.1.3. (34.1.1.3). Then R4. S11. 34.1.1.4. The last one. Up a loopback port on the device R4. Configure it with an address. 4.4.4.4. Mask is 32 bits. We are done configuring. Then do a test. We choose R2 and R3 for testing. Then the thought question just now. I believe you already have the answer. Then let's talk. R2 goes to ping first. Ping 12.1.1.1. See if I can get through. Okay. Pass. Dropped packets. Let's ping again. Ping 24.1.1.4. Okay. It also drops a packet. Prove that R2 and R1 R4 are connected. Let's ping on R3 again. Ping 13.1.1.1. It will not drop packets. 5 all passes. Ping 34.1.1.4. It's also all pass. When we talked about the second floor. Actually told you. Interfaces actually have types. According to the protocol stack. There is an interface called Ethernet port. What you see now on the LAN. All networking projects. The E port you see is called the Ethernet port. 10M. F port is fast Ethernet. 100M. G port is gigabit Ethernet. 1000M. That is 1G interface. Including XG port. 10G. These are Ethernet ports. Running the Ethernet standard. The Ethernet standard is, by default, the switch can be connected in the middle. Then based on this standard, means now inside a network, there may be multiple devices. We need to be on a link, uniquely targeted to a device. For example, I want to communicate with you. Then we must request the other party's MAC. That is, we need an ARP. Let's broadcast first. See where this address is. I can communicate with you only after. This is called the communication standard in Ethernet. You need to make an ARP request. Then when you send the message, packets will definitely be dropped. Then when you sent the message for the first time, you must have timed out the request. Because you are now doing an ARP reply. There's no way you can come back in time. So it times out. So why isn't the packet dropped below? The following is the S port. It is a serial port. Serial port is a technology used in wide area network. That is, interface type under WAN. We don't use. Then its typical characteristics are peer-to-peer. Means there is no